Hello, today we are going to talk about REM sleep behavior disorder as an indicator of Parkinson's disease. Parkinson's disease is a movement-based neurodegenerative disorder that primarily affects men over the age of 50. It is also one of the fastest growing neurodegenerative disorders worldwide, with an estimated 8.5 million diagnoses per year, with rates of diagnosis doubling over the past 25 years. Parkinson's can be associated with certain conditions, like the development of Lewy bodies in the brain. These Lewy bodies can develop prior to the manifestation of noticeable symptoms, making it a useful tool for early diagnosis or monitoring of PD. PD is neurodegenerative in nature and has no cure, so early diagnosis and treatment are crucial. One simple way people can monitor themselves is through the observation of their sleep. Movement in REM sleep can be an early predictor of Parkinson's disease. Movement in REM sleep is known as REM sleep disorder, or RBD for short. In a healthy person, to prevent movement during the REM sleep period, the body undergoes atonia, which is characterized by muscle paralysis except for the eyes. Some researchers believe this occurs because brain waves in REM sleep are almost indistinguishable from wake, so the body undergoes atonia to prevent the enactment of dreams. But what does this all mean? Let's try and break it down for you. Rapid eye movement sleep, often abbreviated as REM sleep, is one of the stages in the sleep cycle. It is characterized by theta waves and makes up 25% of adult sleep. In the second half of the night, REM periods become more frequent, and these periods last longer. To produce REM atonia, the brain relies on three main neurotransmitters: glutamate, GABA, and glycine. These neurotransmitters can be separated into two types: excitatory and inhibitory. Excitatory neurotransmitters, like glutamate, allow neurons to communicate. Inhibitory neurons, on the other hand, like GABA and glycine, prevent communication of information. The subceruleus, which is located in the brainstem, sends out glutamate neurotransmitters to the medulla. The medulla then sends out GABA and glycine to inhibit the motor neurons in the spinal cord. This prevents them from activating during REM sleep, which stops movement regardless of dream intensity. Now, I'm sure you're asking, what causes RBD? And the answer to that is the presence of accumulated Lewy bodies in neural pathways. Lewy bodies form from misfolded and clumped alpha-synuclein proteins. Alpha-synuclein proteins help regulate dopamine circulation, which is essential for proper motor function. So, Lewy bodies are one of the causes of neurodegenerative diseases. The likelihood of producing Lewy bodies increases with age. To simplify this process, let's use the analogy of a light bulb and switch to visualize this. Imagine the subceruleus as the light switch and the medulla as the light bulb. To initiate atonia, the light switch turns off. Despite the switch turning off, the light bulb stays on. This is due to an interruption in communication between the switch and the light bulb. Transposing this onto RBD, the subceruleus is unable to contact the medulla because of the accumulation of Lewy bodies. If the subceruleus can't send its message to the medulla can't tell the motor neurons to quiet down for the night. As a result, the motor neurons continue to fire during REM sleep. In addition, the loss of dopamine due to these misfolded proteins in substantia nigra makes the body more vulnerable to motor dysregulation. These two processes contribute to the exacerbation of the abnormal muscle activity during REM sleep, which is RBD. Now, what is the connection with RBD and Parkinson's? According to the Cleveland Clinic, RBD is associated with certain neurodegenerative disorders, one of which is Parkinson's. About 97% of people who have isolated RBD will have Parkinson's disease within 14 years of diagnosis. In addition, symptoms of RBD can precede more common symptoms of Parkinson's by many years. With the rapid development of PD worldwide, awareness of the connection between RBD and Parkinson's can lead to early treatment. Now that we know the causes behind both disorders, let's talk about diagnosis. Individuals with RBD are often unaware that they enact their dreams during sleep. The disorder is often noticed first by their bed partners. To diagnose RBD, polysomnography is used. It works by tracking electrical activity using electrodes placed on a person's head and face. This type of sleep study provides detailed information about sleep architecture and can reveal sleep patterns like increased sleep latency, decrease in total sleep time, and a decrease in slow wave sleep. The prevalence of RBD is estimated to be between 0.05 and 0.10% of the general population. However, the prevalence increases to about 60% in the Parkinson's population. The symptoms of RBD often precede the more noticeable manifestations of Parkinson's disease by up to 10 years. Monitoring sleep behavior can be a helpful tool in the early diagnosis and intervention of Parkinson's. These early treatments can inhibit the progression of PD. Melatonin is one of the most common medications doctors recommend for RBD patients. This is because of its negligible side effects. It can improve RBD symptoms without worsening other symptoms of PD. Clonazepam is another drug doctors often prescribe to treat RBD and PD. Doctors typically use it for patients that haven't responded to other forms of treatment. In more severe cases, rivastigmine, donepezil, dopaminergic agents, or sodium oxybate may be prescribed. To wrap up, REM sleep behavior disorder offers a unique glimpse into the brain's early changes, often preceding Parkinson's symptoms by years. This link shows how essential it is to pay attention to unusual sleep patterns, particularly vivid or active dream movements while your loved ones are sleeping, as they may be the brain's early alert system. Identifying these signals early can empower patients and doctors to prepare and manage symptoms before Parkinson's disease fully takes hold. By recognizing and addressing REM sleep behavior disorder, we're not just observing a symptom. We're gaining an opportunity to act, protect quality of life, and ultimately stay one step ahead in the face of neurodegenerative disease.